Okay, so Avogadro's number is useful, and so is knowing how many atoms that we have, but really, the thing that the mole helps with is called something called molar mass, right? And it comes from your periodic table. So if you don't have your periodic table handy, I did attach a file so that you can open it up because it helps to look at it while you're doing this. But molar mass is how much mass 1 mole of atoms have. Okay, so the amount of mass in 6.022 or 6.02 times 10 to the 23rd atoms of copper, or 6.022 times 10 to the 23rd atoms of iron. Okay, now these masses actually become numbers that you can physically hold and measure and things we can use in a lab. And what's also nice is those mass numbers are what's written down the periodic table. Okay, so those mass numbers that we've dealt with before when dealing with, isotopes and things like that, that number on the periodic table, like where it says on your periodic table, oxygen has a mass of 16. Oxygen has a mass, a mole of oxygen has a mass of 16 grams. Okay, or a mole of aluminum has a mass of 26.98 grams. Okay, so you get this number off of the periodic table. Alright, so let's work with this a little bit. According to our periodic table, what does 1 mole of single hydrogen atoms weigh? Alright, so that's where you go look at your periodic table. It says 1.008. So we're going to say 1.008 grams. Okay, now hydrogen really doesn't exist by itself unless it's attached to something. So if we're actually dealing with the elemental hydrogen, we're actually dealing with H2. Okay, so really the molar mass of, say, a mole of hydrogen gas would have a mass of 1.008 times 2. Okay, so 2.016 grams. Alright, then looking at your periodic table, a mole of zinc atoms has a mass of 65.38 grams. Okay, so if you're dealing with a single thing off of the periodic table, you can use the number. If you're dealing with, say, a compound like carbon dioxide, okay, you'd take your 12.01 plus 16 times 2. Okay, it should be 32. 44.01 grams. Right, so this is just molar mass. You consider things to be in ones. But let's see what we can use molar mass for. Okay, so quite frequently, and this is especially going to be in the case of labs, you're going to need to do conversions, either from mass to moles or moles to mass. And this is where dimensional analysis, again, is going to come in handy. All right, so let's say we have 25 grams of sodium chloride. So 25.0 grams NaCl. Inside the dimensional analysis, you are going to put the molar mass, because we know 1 mole equals the mass provided on the periodic table. Okay, so to find out the molar mass, what we need to do is combine molar mass of sodium with the molar mass of chlorine. Okay, so we're going to have sodium is 22.99, chlorine is 35.45. If you add those together, you get a 4, carry the 1, 3 and 5, 8, and 58.44 grams per 1 mole of sodium chloride. Okay, so we want to convert to moles, and we want to cancel out the grams. So the 58.44 grams goes in the bottom, and that's equal to 1 mole. So if you calculate this out, you get 0.427789 Okay, and some more decimals after that. If you remember sig figs, we started out with 3 significant digits. We can only keep 3. So it's going to be 0.42, and then 7 is going to be the last digit we can keep. It's followed by a 7, so 428. Then your units will be, I can't squeeze them in here, mole. Okay? So another example. We can go the other way. We know how many moles we have, but we need to know what mass that is. Okay? Because unfortunately we don't have scales that measure in moles. So a lot of times we will need to do these conversions frequently. And we'll get into the reasons why. But moles are more useful in equations, and mass is what we can actually measure with. Okay? So we have 0.5020 moles. And this time we are working with hydrogen sulfate. Okay, so that's going to be 1.008 times 2 plus sulfur, which is 32.07, plus oxygen, which is 16 times 4. If you calculate that, you get 97.078 grams per 1 mole of hydrogen sulfate. Okay, so in this case, where do I want to put the grams? Because this time we have moles, so we're going to want to cancel out moles and convert to grams. So in this case, the grams go on top. And that's the mass of 1 mole of hydrogen sulfate. So again, do your calculation. This time in your calculation, everything's on top, so it's going to be multiplication, and you get 48.733156. To account for sig figs, we have 4 significant digits that we started with. So we get to keep 4873, and that is followed by a 3, so we leave it as 73 grams. Okay, so we will work with these calculations, but your understanding and use of dimensional analysis is essential for doing this correctly. Okay, so if you need help, come in and get it. Don't forget to do the associated quiz, and I'll see you in class.